I started a blog called Web3 IoT a few years ago. Just a passion project, really, covering everything from drones to smart home to smart city to wearable technology. Essentially, if it's connected, we cover it. Emma and I also host the IoT Edinburgh IoTEDI.com Meetup each month. The next event is in Edinburgh, obviously, on Tuesday at Napier University, 6 to 9 p.m. And I've also got a wearable tech company called Nautilus Beam, and we develop or have developed a text input app. If you go out and buy a smartwatch today, whether it's an Apple or an Android Wear device, you have to speak to it. You have to say, hello Siri or OK Google to interact with it, and there you go. It's socially awkward, noise environments, privacy issues. So we've developed a tiny little keyboard for small screens, specifically for smartwatches, that uses artificial intelligence to predict what you're going to type. So it's more of a utility, and we're licensing it to smartwatch OEMs. So, Internet of Things. Things are everywhere. There are connected devices in this room. Everyone who has a smartphone in their pocket or in their bag, that's a connected device. Now that connected device is optimized for people-to-thing communication or people-to-people communication. And the downside is that it's very expensive to manufacture, it's bulky, and more importantly, it's very energy inefficient. You've got to charge your phone, in some cases a couple of times a day. So it's not really optimized for thing-to-thing communication. So most of the things being deployed are going to look a little bit like this. These are the sensors, and they're a little bit like the ears, mouth, and nose. They're tasting, smelling the environment. They're looking out for pollutants, contamination, and in fact, they do put these sensors into shipments of perishable goods. So if there's, like I said, if the perishable goods are going off, or there's any kind of contamination, the sensors will pick that up. So those are the sensors, if you like. These are the brains of the operation. So if you can imagine, a computer, generally they're quite large. These systems on a chip now are so small they can fit onto a thumbnail, so they can be embedded in remote locations, in field monitoring crops, out in the ocean monitoring an industrial asset. And battery technology has always been a problem. Some of these devices, the next generation, are going to be able to go 10 years between being charged. And some of them don't need batteries at all. They'll use energy harvesting, so movement, light, even harvesting RF from the airwaves to power, so no batteries actually required. These devices are kind of larger versions of that. They're like little kits. You wouldn't use them for manufacturing, you'd use them for prototyping and education, so Arduinos and Raspberry Pis and that sort of stuff. They're essentially the same kind of thing. But everything's getting smaller and smaller and smaller. Now, why now? The Internet of Things has been on the hype cycle for so many years. Well, it's because a lot of the sensors I just mentioned, they were too expensive, or they just weren't reliable enough. So you install them on out in a remote location and they break. Or they couldn't withstand the wear and tear that the environment exposes to these sensors. Today, they're finally at a place where they're ridiculously cheap. They have long-lasting batteries, so they can be placed in remote locations. We'll talk about connectivity in a moment. And so you've got this kind of, there's this storm of innovation, all these enabling technologies have matured at the same time. A ridiculously cheap cloud hosting, processing power, the costs have just plummeted. And that's why suddenly we've had this sort of growth spurt of almost doubling. Cisco, a few years ago, estimated 50 billion devices by 2020. I think now that's been downward revised. Gartner is saying more like 20 to 30 billion. But who cares? It's a lot of connected devices. And some of these stats also are astonishing. Just the sheer volume of data that's being harvested from these devices, the amount of value that's going to be contributed to the global economy. So if you can help businesses, particularly industry, that's where the greatest impact will be, which I'll come to in a moment. If you can help industries reduce their operating costs and increase their productivity, that, if you can extrapolate that over all these billions of devices, will create trillions towards the global economy. So it's got to be a good thing. So basically, how these things work. I'm going to use a really simple example: a thermostat. You have a thermostat in your home, for example, the Google Nest, and you've got some data. So the sensor records the temperature. That is then stored or transmitted, and the data is then fed to the person in charge, the house owner, or it's automated. But that's an insight to say, oh, I know what the temperature is, what it should be, and what it is. Are they equal? Well, do nothing. If there's a deviation, well, it has to feed back, and then the data is an insight, and a decision is made, and your home remains at a constant temperature. You have that sort of virtuous cycle. Now, back in the day, if you wanted to change the temperature as a human, you had to interact with a dial to adjust it. Today, with a smart home interface, you can adjust your home thermostat using a Google Nest, for example, from your smartphone anywhere in the world. Tomorrow, all this will be fully automated by AI. Robots are way better than us human beings at doing this sort of stuff. So connected things, as I said, connectivity is an issue, and that's probably one of the roadblocks to deployment. Us humans, we use phones to communicate with things and other humans, and that uses 3G, Wi-Fi, 4G, and soon 5G. So there's a lot of data being consumed, and that's fine because you're within range of a Wi-Fi signal, or you're within range of mains outlets. You can charge these very energy-hungry devices. If you're placing these sensors, like I said, in very remote locations, like in a field, and it's monitoring crop levels or nitrogen levels in the soil, it's not going to be within range of a power socket or a Wi-Fi connection. So increasingly, these low power, wide area networks are being deployed. Not yet, but at some point, the whole entire planet will be covered by these. They're not 3G, they're not 2G, they're kind of like half a G, because that's all the bandwidth you need just to ping a little bit of data back and forth from all these devices that are maybe embedded on high-value industrial assets like wind turbines, to just ping data back and forth to say, are you okay? Yes, I'm fine, or I'm running hot, or there's a vibration, or there's a stress fracture, something's going to break. There's an event that needs to be pinged back. That data is very, very narrow bandwidth. So you don't need 3G or 4G for those types of applications. How do you control these devices? Well, increasingly, like I said, they're being fully automated. Robots are communicating with robots. But us humans still need to interact with these devices. This is gesture. This is Project Solid. It uses near-field radar. So you can actually have really fine, and the API is available now to actually experiment, that you, instead of actually touching and tapping the screen, I can control my watch just by doing things like that. It just makes a lot of sense. Soon it'll be holographic displays and what have you. But today, touch, tap, and swipe, gesture, voice, as I mentioned before, natural language processing has come so far that today with Google Now, Siri, and Cortana, you have kind of a stilted Q&A interaction. But the next generation that are just about to come online use natural language, seamless interaction. Almost exceeding the Turing test, where you're not even sure whether it's a person or a computer you're speaking to. And you'll see that in the workplace, in the home. It'll just be a natural interaction between things and people. And thought, ECG, there are devices we can actually use thought to move cursors across the screen and so on. So industry, that's where the greatest impact is happening. Huge opportunities in industry, just making industry more efficient, which means lower emissions, and increasing profit margins. But you've also got the consumer space. There's things like smartwatches, wearable technology, fashion, retail, consumer. This is just a kind of an overview of some of the verticals that be most greatly affected. I want to focus on the smart home real quick because there is a kind of a war going on, because the big players know how valuable this space will be. And at the heart of it is artificial intelligence. He can, or she can build the best AI, or win the war, as it were. And that's why Facebook, Google, Apple are doubling down and investing in artificial intelligence, because everything will become automated. At the moment, it's not. It's very disjointed, very disconnected. And the problem is that these guys are not playing nice. Google's building their own smart home ecosystem. Samsung and their operating system Tizen. You've got Apple with HomeKit. Apple with HomeKit, and Amazon with Echo, which is a home hub with AI built in called Alexa, and it's a brilliant product. And Amazon has now entered the market, and now they're sort of creating their own ecosystem around these smart devices. So it's just going to frustrate consumers, because if you're kitting out your home with these devices, you're worried that if you buy a device, it's not going to connect with your phone's not going to connect with your smart thermostat, smart thermostat's not going to connect with your smart fridge, and it's just very disjointed because there is no kind of single standard platform. So consumers are sort of naturally stepping back with caution, saying, well, it's going to be the whole VHS Betamax scenario, which standard should I sort of pick? So quite a lot of confusion because of lack of standards, so that's holding things back. Wearables, I don't have time to go into wearables at the moment, but this space it's a really interesting space. There are so many wearable devices that will, within the next few years, start to transform into embeddables, and then they'll be actually placed inside the body. They'll be monitoring your blood oxygen levels, your heart rate, your biometrics 24/7. It'll be shared with medical professionals via the cloud, and it will lead to incredible medical breakthroughs. Mobility, turns out computers and robots are way better at driving than humans are. They don't drive, they don't get stressed or emotional, they don't get tired. It's a no-brainer. Driverless cars will be here, and whether we like it or not, it's going to be a thing. So mobility is a huge, huge space. Internet of flying things, they're not drones at all, they're remotely operated aerial vehicles. With a guy within line of sight, legally they have to. Tomorrow, these things are going to be connected via 5G. It's not really workable with 4G because the latency issues of pinging data back and forth. But once 5G is widely deployed, these things will have machine learning, machine vision, and collision avoidance. They will be able to operate completely safely, completely autonomously. They'll be used in swarms to fight fires, to operate in dangerous areas, cleaning up spills, and this is a really exciting space as well, and there are going to be so many consumer applications that we haven't yet thought of. So, like I said, not really enough time to go into that in much depth. It's a very, very exciting space. Make a movement. Essentially, Jim touched on this briefly. The best way I can describe with regards directly to connected objects. Until today, we have relied on large consumer electronics companies like Samsung, LG, Apple, and others to mass produce electronic products that we end up using as consumers. The maker revolution enables us now, with a little bit of technical capability, but increasingly not much, to buy components off the shelf or print them out and manufacture in small batches or even one-off products that are doing exactly what you want them to do, custom designed for your own requirements, one-to-one tailor-made products, and you disintermediate the big electronic companies. That's the promise of the maker movement. Threats. Cybersecurity is a massive issue. Security is not being taken seriously, and privacy. You're inviting all these connected devices into your own home. They're always on, always listening. Alexa, Google Now. They're always there waiting for you to say Siri or OK Google, adjust the lighting. That's an issue with privacy. Who is harvesting this information? Where is it being stored? And how is it being used? And this whole area of privacy, people are being a bit kind of chilled and laid back about it, but there's going to be a backlash, and this needs to be addressed. And electronic companies they're not locking down connected devices well enough. They're not taking security well enough, in my opinion. Certain companies are doing a very good job, others are not, and that's an issue. If there's going to be a breach, there have been some issues with driverless cars being hacked. So you're just driving along the highway and then suddenly a hacker takes over your car. That's a scary prospect. Power stations, strategically important nuclear power stations, what happens if they get hacked? Security with these things increasingly going online is a problem, or a concern at least. Opportunities, well, I've highlighted quite a few. If you can get the balance between convenience and privacy right as an organization, yes, I'm speaking to Google and Facebook and others, if you can provide seamless services based on the very, very time-sensitive deep dive data, you can deliver much, much better tailored services that we as consumers will benefit from. That's really the promise of the Internet of Things. So we'll have, ultimately, a more convenient and better life. So, I only had one slide. Wow, we got there in the end. And that was really just repeating the fact that there's the good bad world scenario, are the robots going to take over? And there are some genuine concerns that as AI does improve, that they will eventually become sentient, and then there are some scary prospects associated with that. But I think we're way, way, way off, and we're talking about a long, long time before we get to that level. So I think the threats of artificial intelligence and the robots taking over is overstated, but then perhaps I would say that. I think probably smart city initiatives, getting data, getting insights, will make cities cleaner. They will reduce crime, driverless cars and other connected devices, or reduce road deaths. So overall, I think I'm in favour. So, but you guys decide. Is this going to be positive or negative? I suppose it's like yin and yang with any technology, can be used for good or bad. So that, I think, is the last slide. Thank you.